Welcome to this explainer on Nagios and continuous monitoring. Today, we're diving into the absolute bedrock of server health and infrastructure oversight. Because let's be real, if you've ever wondered how massive tech systems stay online 24/7 without crumbling, or how teams actually manage to avoid those dreaded 3 a.m. server crash alerts, you are definitely in the right place. We're going to break down exactly how automated monitoring works behind the scenes. Here's our roadmap for today. First up, we'll ask, why continuous monitoring? Second, we'll introduce Nagios. Third, we'll look at active versus passive monitoring. Fourth, we'll crack open the Nagios architecture. And finally, we'll walk through the 6 phases of monitoring. Let's get right into it. Section 1, why continuous monitoring? It's all about preventing the unexpected. So, picture this. We build these brilliant CI/CD pipelines to automatically test and deploy our code. But what happens after deployment? You wouldn't drive a car for years without ever checking the engine, right? Well, digital servers are absolutely no different. What happens if an application fails silently, or a hacker disrupts the system, or a physical server just completely crashes? Your deployment pipeline might be flawless, but you still need constant, second-by-second eyes on the live environment. And that brings us to this core idea. The fundamental purpose of any monitoring tool is to reduce, or ideally completely avoid, downtime. Think of continuous monitoring like a highly vigilant security guard pacing a bank vault. They aren't actively tackling robbers every second, but if they spot someone acting suspiciously, they intervene before a heist even happens. That's the goal here, catching failures before the whole system crashes and your business just grinds to a halt. All right, moving on to Section 2, introducing Nagios, the industry veteran. To actually achieve this kind of continuous oversight, the industry standard for literally decades has been an open-source tool called Nagios. Sure, there are modern alternatives out there, like Splunk or CloudWatch, but Nagios remains an absolute bedrock. Just look at its timeline. It started way back in 1999 as NetSaint, became Nagios in 2002, dropped its first commercial release in 2009, and launched Nagios Core in 2012. You know, in the tech world, being old usually just means incredibly reliable. Its longevity is for sure its greatest strength, giving it unparalleled stability, fantastic documentation, and a massive library of customizable plugins. It's truly battle-tested. Now, for the technical engineers tuning in, you'll probably love this little detail. Nagios natively communicates over specific default port numbers to actively sense and request data from client nodes. And the magic number? 5666. If you've ever spent hours ripping your hair out troubleshooting a firewall, 5666 is usually that magic gateway Nagios uses to ping a server and basically ask, hey, are you still healthy? That takes us to Section 3, active versus passive monitoring. Basically, how the server checks in. So Nagios tracks your infrastructure's health using 2 totally distinct communication styles. In active monitoring, the central server initiates the conversation. It's kind of like a proactive teacher walking up to a student's desk every single day to check their homework. Passive monitoring, on the other hand, is when the remote client takes the initiative to send its status to the server, much like a student who only walks up to the teacher when they actually have a problem or a question. Let's really cement that passive monitoring concept with an analogy. Imagine you're expecting a daily newspaper delivery. As long as the delivery boy drops it off, your status is okay. But if a client node that passively reports its health every minute suddenly goes totally silent, the Nagios server instantly knows there's a disruption. Just like realizing your paper didn't arrive, in this case, the silence itself is the alarm. Okay, Section 4, the Nagios architecture. Let's take a peek behind the scenes. So, how does Nagios actually execute all these checks under the hood? Well, it operates on a very strict client-server architecture. You've got one central brain, the primary Nagios server, and then you have multiple remote clients, or target nodes. These target nodes are your everyday working servers, your databases, and your web applications that the central server is constantly keeping an eye on. Now, inside that central engine, we have 4 main components working together. First, there's the configuration file. Think of this as the master list. It stores the target IP addresses, login credentials, and the exact metrics you want to monitor. Second is the daemon. This is the active engine that reads that config file and actually goes out and initiates the health checks. Third, we have the database, which securely stores all that locally collected status data. And finally, the web dashboard, which takes all that raw data and gives you a visual interface full of green, yellow, and red status indicators. But wait, how does the server actually get inside the client machine to check on things? The real magic here happens through a crucial plugin called NRPE, or the Nagios Remote Plugin Executor. Think of it like sending an inspector to a remote branch office. If the inspector doesn't have a contact on the inside to open the front door, they're locked out. The Nagios daemon uses NRPE to securely reach out to an NRPE agent sitting inside that remote machine. That agent opens the door, gathers the specific metrics like CPU load or HTTP status, and hands that data right back to the server. And this quick math illustrates just how fast your monitoring load scales up. In Nagios terminology, every single thing you monitor is called a service. So if you have 5 target servers and you want to monitor 4 specific metrics on each of them, say HTTP, SSH, FTP, and SMTP, Nagios multiplies those out to track 20 distinct services on your dashboard simultaneously. It gives you this incredibly granular bird's-eye view of your entire infrastructure.
Which brings us to our final section, Part 5. The 6 phases of monitoring, the continuous cycle.
You know, whether you use Nagios or maybe something like Splunk or Prometheus, continuous monitoring always follows a specific repeating life cycle. It's basically like building a house. Step 1, you define the blueprint of what you need to monitor. Step 2, you establish your parameters like thresholds and IPs. Step 3, you implement the tools and turn them on. Step 4, you analyze the data coming back. Step 5, you respond to any alerts. And Step 6, you review the process to update and improve your systems. During that analyze and respond phase, your dashboard is going to throw some different alerts at you. Normal obviously means the system is totally healthy. Warning means a parameter is degrading. It's struggling, but it's still alive. And critical means a failure has actually occurred. By constantly analyzing this loop, your action plan is to catch a warning status and isolate or fix that failing node immediately. It's the digital equivalent of noticing a slow leak in a tire and swapping it out before you have a catastrophic, highly stressful blowout on the highway. So we've covered a ton of ground today, from the why of continuous monitoring to the nuts and bolts of the Nagios architecture. Automation is fantastic, but without continuous oversight, you're essentially flying blind. As you look at your own setups, ask yourself, if continuous monitoring is the tireless, high-speed security guard for your digital assets, what unseen vulnerabilities might your unmonitored systems be hiding in the dark right now? Thanks so much for joining me on this explainer, and I hope it sparks some great conversations about the health of your own networks.